Hi guys, welcome to my YouTube channel. Uh, so, uh, Hi guys, welcome to my YouTube channel. Today's topic is OpenSIP RTP engine integration and transcoding. I will show various kind of transcoding we can do with RTP engine and how to integrate OpenSIPs with RTP engine. So various transcodings are possible with various codecs. G729 is one of the special codec which is used for transcoding most of the cases. So I am going to discuss about all this today. So before going to start discussing, I just want to remind guys, please don't forget to like, share, and subscribe to my channel. Uh, So let's start. So those who are new to C VoIP and RTP, I will request you to go through these two videos that I have uploaded earlier, so that you can get a good knowledge about C VoIP, RTP, how it works, what is SIP and what is VoIP, and how RTP works with VoIPs. So if you go through this video, you will get a good idea how it works. So it will be easy for you to understand how it transcoding and other stuff works with OpenShift. So, as today's topic is to discuss about OpenShift, so let's first know what is OpenShift and what is RTP engine. I know most of the guys who are seeing this video are aware about OpenShift and RTP engine, but this is for the new guys who are interested to learn. So, let's first see what is OpenShift. So, OpenShift is nothing but a SIP stack which can be used as a registrar or as a proxy. So here I will use for my demo purpose I will use OpenShips as a registrar. So let's see what is OpenShips. So for this demo I will use OpenShift 2.3.2. So just search in Google, you will get the documentation related to OpenShift 2.3.2. So just opening this. So these are the all the modules are defined. I am not going to discuss in details today how OpenShift work, how to do programming in OpenShift. I am expecting that you already know OpenShift programming, and if you have some queries or comments, you just let me know in comments so that I will release a few more videos related to this, how to program OpenShift in details. So today's topic is advanced topic. So I am just going to discuss about RTP engine, how to integrate OpenShift and RTP engine. So let's see the RTP engine document here. So this is the module which defines the RTP engine. So let's see. This will come. This is required for this demo purpose. So this is how OpenShift and RTP engine module is there. So before going to discuss about RTP engine, so you get an idea of what is OpenShift. So here I will use it as a register purposes. So I will do a registration and I will make call to the endpoints and I will show how the transcoding works. So this is this is what is OpenShift. So you have to go through details. So another is what is RTP engine. So let's search for RTP engine. RTP engine is nothing but an RTP stack. So OpenShift basically is a SIP stack, and it needs an RTP engine to for the voice purposes. So it integrates with RTP engine, and RTP engine is a RTP stack which will allow end-to-end voice connectivity. So these are two separate modules work together to establish a SIP call with voice. So let's see what is RTP engine. So here you will get the RTP engine source. You can download it from here, and you can install and use it for uh, So here is the source and the documentation is available here. How RTP engine works, what are the various requirements of RTP engine. So how to integrate RTP engine and OpenShips. This is what I will discuss today. So basically, before going to discuss this, let's see what is transcoding. As I am going to discuss about transcoding today, so let's first get a good basic idea what is RTP engine. So what is transcoding? So let's say uh, whenever voice call is established, the codec is used for establishing the voice call. So that codecs normally compresses the voice data and sends to the end party, and party decrypts that data, and it plays back to the end client. So now there are why we need transcoding. Basically, there are various kind of codecs are available which can be negotiated during call. There are G711 codec, there are G729 codec, J723 codec. So the difference between these codecs are regarding the bandwidth uses. Now some G711 codecs are uses high bandwidth. G729 is a very compressed codec, but it uses very low bandwidth. But it uses CPU resources very high because of the compression techniques used. So but when you are in an internet and you are getting call, you cannot pass G711 all the cases because it will utilize your most of the bandwidth. So those cases people uh, set G729 as preferred codec. They expect to connect the call in G729. So what happens here, like you got a provider carrier network which is working in G723 or G711, and other end you wanted to use G729 because of the bandwidth resource utilization you want to reduce. So that is where the transcoding is required. Here the session border controller, RTP engines. So here it will sit and it will transcode the packets. So whatever packets are coming in G711, it will transcode it to G729 and send it to the end party. This is what is transcoding, and it will reduce the bandwidth uses. But this transcoding also costs the CPU uses. So there some limit is put to reduce the CPU uses as well. So this is what is transcoding. So let's see how SIP negotiation works, because the RTP whatever call is established, their RTP is used. So how the transcoding works or how the voice call established, that we need to understand first. So A party sends call to B party with SDP, then it sends ringing, then it sends 200 OK. So in SDP it offers the codec, like A party sends these two codecs to B party, then B party can select on one of the preferred codec and respond back to the A party. So this is one example. If you open the traces with Wireshark, you will see that how the codec negotiation happens in media description. So here you see A party send two codecs, PCMU and PCMA, and B party respond back with PCMU codec or PCMA codec. It can select based on the preferred codec. So here the call will established in PCMU. So this is a normal SDP negotiation between two endpoints. Now, in case of transcoding, it's possible that A party send PCMU and PCMA, but when the SBC forwards it, it can do the transcoding and it can send G729 as the preferred codec to B party, and B party will respond with G729. So one end it will be PCMA or PCMU, other end it will be G729. So this is what all description about. Now let's see how OpenShips integrates with RTP engine. So I am not going to discuss details about how OpenShips scripting need to be done or source code need to be done. So I am just showing you how the RTP engine part works. So here you can see that RTP engine, you have to include an RTP engine module file. These are SO files, and you have to define RTP engine and the IP address where you want to where your RTP engine is running. So let's. I'm showing an example here. I have a sample script here. So So let's see here. I have integrated RTP engine here. So you are seeing that the RTP engine module uh, I have included here, and I have connected my RTP engine. My local address where this OpenSIPS is running is 105, and I am running RTP engine on another server 172.16.15.10 on this port. So it's very important how this works, how to understand. So this is my local server, and I am running RTP engine on another server. So let's see here. So this is my RTP engine running here. So this is my IP address 10. So I have started my RTP engine here. So this is the command to start an RTP engine. I have installed RTP engine here. So this is the command to start the RTP engine. So you can see that the port where it's listening is this. So let's show you how RTP engine connects here. I just restarted my OpenShips. So let's see the logs here. See here, this 10 one RTP engine is running, so it's saying found RTP proxy, and it is enabled. And here 105 I am not running any RTP engine on this port, so it didn't find the and it disabled it. So there is a command to check. So you can see that this RTP engine is connected TP0. Here it's timing out, so it's not enabled. So it connected through 10. So this is how the RTP engine integration is done. So here I have installed the RTP engine. I have run the RTP engine here, and uh, I have mentioned the RTP engine in my OpenShift CLG, and I have started it. So this is how the RTP engine integration is done with OpenShift. Now let's see. Okay, there are other ways of integrating the RTP engine. If you want to group a set of group, also you can define. Say for example, you want to run one RTP engine or two RTP engines for one purpose, another two RTP engines for another purpose. So like you want a few RTP engines to connect to some trunk, you want another set of RTP engines connect to another trunk. So there you can do a different groups. Like while grouping, you can mention group number. Here is an example. This is how you can define the group numbers. And in your RTP engine route, you can wherever you want, you can based on the condition, you can select which group to use. So this is the way you can select the groups. So this is the command you already know how to start a RTP engine. So here also one, this is the port number. Here you can mention the maximum port numbers from which port to which port it will open. So whenever call establishes, you need when there are huge number of calls are there, you have to mention a big range of ports. So here you can mention which port to which port it shall utilize. And there here is log facility mentioned. It will have some kind of a logging facility where you can mention the log level, like log level 3, log level 3 up to is okay. If you want to debug, you can mention log level 4 or 5, 7 up to 7. So this is how RTP engine uh, parameters works. So let's see now. How you will mention in so. So when a call establishes, how you will mention the RTP engine, how you will invoke the RTP engine. So there is a command in OpenShips, it's called RTP engine offer. Then when it answered gets answered, you have to use the RTP engine answer and you have to pass the flex. So let's see the RTP engine module now. So here is the RTP engine module. Here is mentioned clearly how to use these, what are the various parameters you have to use. Then here is the RTP engine offer. So this RTP engine offer, you can mention the parameters, like various parameters I mentioned. So you can go through all these parameters, but for voice call you need RTP ABP, and you can enable various parameters like ABPF options are there, SRTP options are there. So based on the requirement, you can enable all these points. So here we will mostly focus on voice call for this demo purpose. So for voice call, these are the enough parameters like RTP, ABP. Uh, these are the parameters, and you want to, if you wish to remove ice, then you can IC, then you can remove it. Then when your invite will come, you will send invite to other end party. So there you will mention RTP engine offer the flags that are required. And when you will get an answer back in the reply, you will mention the answer, RTP engine answer. So what happens when you invoke RTP engine offer? So uh, see here, RTP engine offer will send these parameters to RTP engine. Like in my case, the RTP engine is running on this server. So whenever any invite will come, it will when RTP engine offer will be invoked, this OpenShift will send these parameters to this with the SDP. It will pass the SDP and create a RTP connection, and it will give you the SDP and whatever offer you want to send. So it will give you the SDP back to the OpenShift it with the ports, media ports, and all this whatever is open in RTP engine stack. So OpenShift will offer this invite accordingly to the B party. So this is how it works. So let's see how it works. So if you see any example, you will see the root mentioned in RTP engine. So whenever any invite comes, this root is invoked in the CFG. So there you can mention which kind of things you want to expose to the end user. So like here I have mentioned, I will for a normal SIP call, I will invoke it like this, and when I will get a reply back, I will invoke it like this. So this is where. So this is how it works. Now let's see an example how it works. So I have one phone light. I already configured it to register to this server. So I am registering this to this server. So there is another phone I have registered with another media proxy. It's already registered with this. So I am calling from this to this. So I got a call here, it got answered, and call is established codec. So now I am disconnecting this. Okay. So it got disconnected. So you can see here when the invite came, I have invoked the RTP engine with these parameters, and when I got the response back, I invoked the RTP engine with these parameters. So this is the way it works, and this is the so here I have an example of a normal. I have captured these trees earlier, so here is an example how it worked. So from here you can see my phone number is 3334 and this phone number which is registered with OpenSIPS is 2004. So this is 2004. So I initiated a call to 2004 from 203334. So so here one more option to check. Here I have set only PCMA codec as my audio codec. So here you can see I have set PCMA codec. So in offer, only PCMA codec is sent to the end party. So this is my media proxy. From this proxy, I got a call to OpenSIP. OpenSIP forward this call to my registered endpoint to Phonerlite. So while sending it to Phonerlite, what happens here? So it got an invite from the media proxy. So from the proxy, after getting the invite, it invoked the RTP engine, and RTP engine replied with this SDP codec, and it filled the SDP codec and sent it to the B party. So a normal PCMA call is established. So it respond back with because this Phonerlite also support PCMA, so it respond back with PCMA. So it also send back this PCMA to the media proxy, and a PCMA call got established. So this is how it worked. So now let's see how the RTP engine will be used for transcoding purposes. So I am making a small change here, as I showed you. Let's before going to discuss this, I'm just going to show you how. So transcoding, there is option in OpenSIPs. It's described here. Here it's mentioned like how you will transcode the codecs. So transcode PCMA. So you can go through this documentation. So how you will mask the codec, how strip the codec, how to transcode the codecs, all are mentioned here. So accordingly, I have defined it here. So here you can see you can mask all the codecs and offer only G722 to the other end. So this is how you can mask all codec you want to transcode to PCMU only. So this is how you can do the transcoding. So what this will do is it will remove all the codecs from the incoming invite, and it will add PCMU, and it will only offer PCMU to the B party, and A party can continue with the preferred codec, any of the preferred codec. So similarly, you can do the G729 transcoding also required. Can do this transcoding similarly. But for G729 transcoding, you have a special option you have to enable. You have to, while installing the RTP engine, you have to do this. This is required for G729 support. So you have to install the RTP engine with this library to support G729. So let's see one example now how the transcoding works. So here I am in the RTP engine root. I am just normal root. I am removing. I am adding this G729 transcoding. Okay, so let's see now. So now I am registering this again. So I have registered it and I'm making another call now. Hello, hello, transcoding testing. So you see the call is established with transcoding feature. So let's see here. When I made a call, it invoked the RTP engine with transcoded PCME. So let's see, I have captured the same trace earlier and I am showing you how this transcoding worked here. So here again, the call came with PCMA, but here now, while while sending these, OpenSys changed the codec to PCMA because I did transcode PCMA option, so it offered PCMA, but initial offer it got in PCMA, but it sent an offer to PCMA. As Phonology support PCMA, so it returned with PCMA. And when it sent a media proxy answer, it changed the codec to PCMA. So here PCMA to PCMA transcoding is done. So this is how it worked for PCMA and PCMU. So let's see here the two options. Now here when you see I'm making a call, here you see the ULO call is established. Okay guys, so this is how the transcoding works. So just if you like this video, please don't forget to subscribe, share and put your comments if you have any questions or if you want any kind of support on other topics. You can write it in comment box, so I will check and respond or upload videos accordingly. So guys, thanks, but before ending this video I just want to remind you that I just want to tell, in if you are interested, I will discuss all this. Like RTP engine has some recording features. RTP engine and OpenShips behind the firewall. When RTP engine and NAT are behind the firewall on private IP, how it works and how it sends it to the public IP. So this also I will discuss if you guys are interested and if you guys want to more sessions on this, then I will write OpenShift programming, how to do the programming, how to write the OpenShift CFG, all these things I will discuss. Then how OpenShift Homer integration done, how Homer works, all these details I will put. OpenShift as an SVC, you can use OpenShift as a proxy as well, where you can integrate your SIP trunks. Terminate your zip trunk. So this will also, this is separate topic. I will discuss this. I will release videos. So guys, keep subscribed so that I will get interested to upload more videos like OpenShift's WebRTC integration, OpenShift as a registrar, then OpenShift's asterisk integration and register and SVC free switch integration. So all this I will discuss in my next videos, upcoming videos. So guys, please subscribe. Don't forget to like and share. So and comments. So guys, thanks for watching this video. Thank you.